Okay, so now that we have finished discussing all about areas, kung paano kinukuha yung area between two curves, so let's move forward naman dun sa ating tinatawag na volume of solid revolution or the single integral. Kasi on the preceding sections, you will be learning some double or multiple integrals. But for this case kasi, we're only dealing with the single integrals, and that's the volume of solid revolution. So when we say volume of solid revolution, it only means na we have an area and then we're trying to rotate that on the an axis or probably a certain line, and we call that the axis of revolution. So ganun lang ginagawa natin. And we actually have two methods that we employ in this volume of solid revolution. So we have disk method and then the shell method. So unahin natin muna yung disk method. So again, this volume of solid revolution, this is just the area, or it could be a simple line lang, basta within those limits of integration, and then we're trying to rotate that certain area on that axis of revolution. So basically, this is what happens, no? You have a graph, let's say meron kang, ito yung graph mo, initially this line, diba? And then you will draw a representative rectangle which is actually coming from that certain area na kinakopy natin before. Kasi diba, when we try to compute for the area, we always try to draw a strip. It's either a vertical or horizontal strip. So ito rin yung magiging representative element natin for volumes. Now, yung representative rectangle na yon, with respect dun sa axis of revolution, silang dalawa magdidikta kung ano ba yung gagamitin natin na volume of our solid of revolution. So remember this, when the element, let's say the vertical or the horizontal element, kung alin man yung ginamit natin or yung strip, whenever it is drawn perpendicular to the axis of revolution, we will always use the formula that is presented here. The volume of the disk is equal to the area of the disk times the width of the disk, which is actually pi r squared width. Paano ba nangyari yon? So imagine nyo meron kayong certain disk, and then nirevolve natin siya around the, let's say, x-axis, no? So, di ba makaka-form kayo ng certain disk dyan, and you know quite well that this measurement is actually r, which is the radius from the center of that graph. But how do we represent this in terms of the integral expression, ano? So remember, sabi natin meron tayong volume in terms of pi r squared and then the width. So alam naman natin na yung W, which is the obtained from the, let's say, ito nga, vertical strip natin, that's actually the delta x. So mapansin nyo, yung W parang siya yung delta x. So if we want to represent this in terms of the integral, we could say na yung v natin is meron agad yung dx kasi yun yung W. So we just need to find this r squared kasi this one is your pi, parang constant lang siya. So meron agad yung pi automatic. So what is your r squared? So that is actually parang representation siya ng area natin, no? And knowing that we have the formula for the area, that's AB, and then you have f of x, so parang minus g of x kung meron man siyang opening. So let's just assume na meron tayong f of x lang for this case. So that is your dx. So parang ganyan yung area natin, no? But then again, ang f of x natin is actually the measurement from this point going to that f of x. So we know very well that in this case, if that is f of x, then yung ating portion na kailangan lang natin is this f of x, and then we have to square that. That's because r squared tong nandito. So that means na you have a to b and then f of x quantity squared, which in turn, this is the expression that we use in terms of r of x, which is actually just the function itself. So, halimbawa, given kayo na, let's say, ln x plus 3. So, yun na yung gagamitin natin. It's just that you have to make sure na you're using the perpendicular, the element of the strip that you're using is actually perpendicular to the axis of revolution. So, ito yun. Okay, and then it could be dy depende sa inyong axis of revolution. So, yun yung sinasabi ko na kanina na nangyayari. Now, itong disk method, it could be extended in a way na magiging washer siya. Ano bang ibig sabihin ko doon? May mga times kasi na may hole yung ating figure. Let us say we have this one. So, di ba magkakaroon siya ng hole in this case. So, It's not actually a disk but a washer. So for that case kasi, tandaan niyo yun, 'di ba? F of x lang yung kanina. Pero pag yung ang ating area, hinahanapan natin area between curves, 'di ba? We use yung ating f of x minus g of x. In this case lang kasi, nagkakaroon tayo ng square and then square dun sa second function, and that's the same parang method na rin. Just add pi at that certain formula. So to show you a more vivid example of this, I'll be using a GeoGebra here to help you visualize what's happening in this case. So, for example, I have a function. So, eto hindi naman kayo required mag-download ito. It's just for your aid para ma-visualize nyo yung nangyayari sa ating graph, no? So, unahin ko is, I'll be writing a function here just to show you what happens. So, simplihan lang natin. Yung function ko is y is equal to x. So, that means parang isang certain diagonal line lang yan. And then, I'll start with, let's say, 0 yung aking, yung domain ko is from 0 to, let's say, 3 units na lang para mas simple. Okay? Para hindi tayo maging complex. So, yan, kita nyo yan. This is the x-axis, this is the y-axis, and then this is the z-axis, yung blue. So, just don't mind yung z-axis kasi medyo 3D tayo ngayon, kaya parang kailangan natin ng z. Pero I'm just concerned with this x and y. So, that is your function. That is, let's have another color dito. So, yan. So, nakita nyo yan. Ito yung inyong function. That's y is equal to x. And then, the domain is from 0 to positive 3. Okay? Now, I will try to draw a vertical element. Pero syempre, hindi ko siya kayang i-draw dito sa ating, sa ating GeoGebra. So, I'll be drawing it here. So, medyo nakaslant yung ating axis dito. So, i-slant ko lang din. Pero this is a straight, supposedly a straight vertical element. So, ganyan siya, no? Okay? So, hopefully ay nag-guess siya. So, pag parang ina natin siya, minove natin. Sorry. Pag ina natin siya, ay joke, hindi kasi hindi nga pala matasama yung So, yan. Basta, pag tinwitch natin to, medyo mag-straight yan. So, that is my vertical element. Kasi kung mapansin nyo, patayo siya, diba? And this is actually your dx kasi this is the change in x. Okay, so that's your dx, and then this is your f of x, which is just the distance from the x-axis going to your function f of x, and this is your y is equal to x. Okay, so yan yung vertical element niya. So ang i-rotate ko siya along the x-axis. So ganun yung mangyayari, i-rotate ko siya, no? So you have to expect na yung magiging figure nito is syempre para siyang cone kasi i-rotate ko tong mismong area nito from 0 to positive 3. So, parang ito yung kabuuan ng area niyan. I-rotate ko siya ngayon sa x-axis. So, meron ditong certain function na I can use. So, I think it's here. And then, surface of revolution. So, I'll be dragging this to somewhere here. Okay. So, yan. Okay. 360 degrees. Oops. Ayan. Okay na siguro yan. Okay, so kung mapapansin nyo, yung figure natin is something like this. So, hopefully ay na-visualize siya na mas maayos. So, diba, even though this is not actually yung disk, kasi kung mapapansin din na siya disk, para siyang cone. But the idea here is that when you try to draw the figure, para makakabuo ka ng certain volume dyan, wherein kapag nilagyan mo siya ng parang laman doon sa loob, makukuha mo yung parang volume niyan, di ba? Which is actually the disk obtained from this kind of expression. Kasi ang dito is parang yung mismong vertical element natin is nakalapat mismo siya dun sa ating axis of revolution. That's why we call this the disk method. So, ganun siya. Now, what if we have another function? Let's say, maglalagay pa ako ng isang function. Let's say that is g of x. And then starting value ko would be, let's say, starting from 2 and then ending up with also, let's say, 3. Okay? So, yun yung aking new function, and that's g of x. So, mapansin nyo from this, dito lang tayo nag-start sa 2. Let's say, na lang din, sa 0 din tayo mag-start pala para parehas tayo. Okay? So, ayan, magkasing haba sila, pero ito, medyo umakyat siya, no? And then, I will try to revolve this to, around the x-axis lang din. So, what happens to that? So, kung mapansin nyo, pag naggawa tayo dito ng element, ng ating tinatawag na vertical element, no? So, ito yon. 'Di ba? Hanggang dyan siya. But we have to understand na yung ating area dito sa, I mean, yung volume natin would be going from this point tsaka abot hanggang dun sa may dulo dun. So, I'll try to revolve this using the function here and then along the x-axis. Okay? Alright. Now, kung mapapansin nyo itong figure na to, butas siya dito sa portion na to, no? Which is dun nga yung 2 units above the 0, 0. So, dito kasi, dun sa ating figure kasi x plus 2 yan. So, syempre, nag-shift na tayo upward. So, what I'm trying to say here is that kapag meron tayong certain vertical element or horizontal, it could be. So, once na they are perpendicular and mismong nakalapat siya dun sa ating axis of revolution, we can form a disk. And the formula that you'll be using is this, yan, pi and then from c to d and then ry squared or rx squared, yun lang yan. But kapag meron tayong certain portion wherein, kung mapapansin sa graph na to, so yung graph na yan, di ba, medyo butas siya dun sa 0 to 2. So, ibig sabihin nun, hindi siya disk, kundi washer siya. Kasi nga, mayroon certain portion siya na hindi naka-account dun sa kanyang volume. So, what you have to do is to square mo na yung function and subtract mo kung ano man yung hindi kasama dun sa function na yun. So, yun, ganun yung ating sinasabi na washer and disk. But they are under the same formula lang din, under disk method. Kasi diba sabi ko, generally there are two, the disk and then the shell method. So yung disk, para nahati siya into yung exact disk at saka yung parang washer method. So parang ganun siya. So hindi pa to shell method, ito yung under pa rin ng disk method. Ito nga lang is parang washer kasi butas siya. So just remember that kapag butas yung inyong figure and then you try to rotate that, so, kailangan magkaroon kayo ng washer. So, basically, kailangan square mo muna yung first function, then subtract mo yung square ng second function na nagpabutas sa kanya. Okay, and I think we can move forward na dito sa ating, ito, i-discuss ko to sa last portion, and then I think we should move forward muna sa shell method bago tayo mag-proceed sa problem solving. So, ano bang pinagkaiba ng figure na mabubuo sa shell method and then sa disk method? So, wala talaga silang pinagkaiba. Actually, same lang yung figure. Pag tiningnan mo siya, a virtue ng parang perspective ng volume of solid revolution. So, kung ano man yung mabubuo sa ating disk method, it should be the same lang din sa ating sa shell method. Pero ano bang pinagkaiba ng dalawang to? Ang pinagkaiba lang nilang dalawa is all about the relationship between the element that you're using and then yung axis of revolution. Again, I have to emphasize that when you use disk method or shell method, disk method or washer method, any of the two, your element or your representative element that you're using is always perpendicular to the axis of revolution. So, in short, kapag meron kang certain graph, let's say this is your x and y axis. So, meron kang graph, and then this is your vertical element. So, you have to make sure na you're revolving an axis that is perpendicular to your vertical. That is, of course, yung nasa y axis. Or pwede rin siya dito. Pwede mo rin siyang i-revolve dyan. Basta kailangan perpendicular sila. And this is, the formula would be pi and then yung ating rx, quantity squared, and then dx. So, you can use that. Or, kapag halimbawa naman, you're using, halimbawa, ganito yung figure mo, and then you're using the horizontal strip. So, ito yan, horizontal strip. You have to make sure na you'll be revolving around this y-axis naman. Kasi, you have to make sure na perpendicular ka lagi dun sa iyong axis of revolution. So, in this case, that's pi and then parang, r of y and then squared dy. So, ganun yung magiging formula mo dyan. But, what if this is the case now? Meron kang certain x and y axis and then meron kang certain graph. So, nagawa ka ngayon ng vertical strip. Okay? And then, instead of revolving this dito, kasi supposedly pag nirevolve mo siya dito, that is the disk method. Dito mo siya nirevolve. Okay? So, that is parallel. The vertical element here or the element is generally parallel to the axis of revolution. So that means you will be using the shell method in this case. And the formula should be the shell method. So when we go back to your lecture, the formula for the shell method is written as this one, the 2 pi then the average radius, height, and thickness. Kasi that's how we solve the volume of a certain cylinder, diba? That's why it is called the shell method. Kasi parang gumagawa tayo ng certain cylinders in this case. Kaya kung mapasin nyo, cylinder na buo dito, diba? So that is simply the formula, 2 pi, and then that is CD. So itong py na to, that is the distance from this axis of revolution going to that certain radius, and then hy dy. So ang hy dy natin is this one. Okay, ito yung h natin, which is actually parang yung length ng ating cylinder. So ayun, so kung mapansin niyo, ito na yung basic representation niya. So we have py, that is the distance from your representative element, and then yung hy mo would be the length of that certain element. So pag naman patayo siya, ano ba yung p of x mo? So literally yung p of x mo is actually yung distance from the axis of revolution going to that certain element, and then yung h of x mo would be this length of your curve, ganon. And usually this length of curve is your f of x. Usually ganon siya. And ano ba yung h of x? So usually this is just the distance. Let's say distance nito from this portion going to this portion. So literally that's your x, diba? Kasi distance lang naman yan, hindi mo alam yung distance, so that's x. Pero ito, this patayong distance, that is usually your function. Okay, so ganon siya ginagawa. And then let's go back here sa GeoGebra just to show you. So again, I have to emphasize na walang pinagkaiba yung itsura ng figure dun sa ating disk and shell. It's just that nag-iiba tayo ng orientation ng strips or ng elements dun sa ating axis of revolution. Yun lang yung kailangan natin tandaan dito. So let's have a summary of the formula para mabilis. So meron tayo dito mga certain formulas na we have, and this is the comparison of disk and shell method. So kailangan masolo nyo to para at least lagi kayong tama sa paggamit ng formula. Kasi kung mamamali kayo, edi hindi makukuha ng tama yung sagot. And there are cases na mas madaling gamitin ng shell kaysa sa disk and vice versa. Di ba nasabi ko rin yun before sa area, na may mga times mas madaling vertical strip sa horizontal strip. So that also applies in this case. So kung mapansin nyo, let's take a look at the first example. So this is your element, and that is a horizontal element, no? The axis of revolution is on the y-axis. So remember, if this horizontal strip is perpendicular to this axis of revolution, so this is what we call a disk method. So the formula is, syempre, disk method yan. Pero syempre, may ano dito, may hole yan. Kung mapansin, may hole, kaya ang form nito is in the washer method. Okay? So let's have a look at this one. So meron tayong vertical strip, and then the axis of revolution is along the x-axis, which is actually perpendicular. So in this case, that is the disk method, pero since may hole siya, so that's washer in this case. Now for this one, meron tayong vertical strip, okay? And then the vertical strip is rotated around the y-axis, which is actually parallel to that. So having this distance parallel, so that means na this is a shell method. So ayan, sinasabi naman dito na representative rectangle is parallel to the axis of revolution, and that's the same thing that goes for this second or the last example. Okay, so hopefully malino yung discussion kung kailan ginagamit tong two formulas of volume, kasi baka ma-mix up nyo tong dalawang to, which is well, it results to a wrong answer. So before we proceed with the problem solving muna, let me answer this. When to use disk over shell or vice versa? So ito, may sagot din naman dyan. Sabi ko nga, una, ang kailangan nating makita doon is that if it is a lot easier for you to integrate using that function, and it is a lot easier to represent. So that's also that is one of the parang foundation. Pero knowing na I allow you na to use your calculator to directly integrate that, just write the expression. So I think the most important factor na you can consider here is the parang yung pinakamadaling construction ng inyong function in a way na isa lang volume yung hanapin nyo. Kasi do you know that there are times that you also have to compute two volumes just to determine yung final volume ng inyong figure. Kasi that's the same thing that goes for areas as well. So, it also applies for the volume. So, yun na siguro yung pinaka-important natin factor. And then, if a solution exists for this method, does that mean that there should be another solution using the shell method? Yes, the answer is yes. But there are times na sobrang hirap kasing integrate nung portion na pag naka-shell na siya rather than the disk or vice versa. So, for that case, minsan mahirap siyang hanapin pero there should be another solution that exists in another method. So, what is the difference between washer and disk? I think nasagot ko na to, paulit-ulit na to. Why isn't there a washer method for shell method? Now, if you'll be looking at this figure, kahit may certain parang pugwang dito or certain hole or kahit nakalapat pa siya, 'di ba, we can just produce a shell here. Meaning, pag sinabi nating shell, parang para siyang cylinder. So, kahit pa siya ibutas or hindi, makakabuo pa rin tayo ng cylinder. That's the concept of shell method. And kahit pa may butas yan or wala, it's just the same thing. Kaya, hindi natin kailangan magkaroon ng washer method dito kasi we're bound by the fact that we're considering the average distance between this vertical element to the axis of revolution. So, even if there is a certain hole and between that a certain distance, so wala nang tayong doon. Wala nang kaso yun kasi we can also determine that using the same formula. So, in short, kung shell method, mas parang generally, isa lang yung formula natin gagamitin. Kaya, madali siya. Well, that is given kung madali siyang i-write in terms of shell method. So, and number 5, why is this topic so difficult? So, siguro mas malalaman nyo pa yung sagot dito pag nag-solve na tayo. Pero, to answer this, mahirap siya kasi kailangan nating i-represent yung ating mga figures natin in terms of parang drawings. And what makes this a lot difficult is that before kasi I don't allow parang mga tools or software. So ngayon, I think it's better to allow it kasi we're on a virtual setting and then it's really difficult for me to reach out by drawing it. So might as well use na lang siguro yung ating mga tools, and GeoGebra is a very good example at this in drawing the solid of revolution. Okay, so nasa loading screen tuloy tayo ng GeoGebra. Anyway, so we're done with the facts, so I think we can now solve for one of the examples here in our handout. I'll be solving yung ilan ba example dito. So ito actually given na to, inisa-isa natin pa yan. So, solving natin siya later. And I think, ano ba yung given dito? So, meron tayong, marami pala naman. So, I hope you can answer this. Pero I think I'll be doing odd numbers naman tayo ngayon. Okay?